Hey guys, welcome back to Calculus Universalis. Today we're going to be doing related rates, so let's get into it. So our first problem is going to be, we're going to have a 10-foot ladder leaning against a vertical wall, just like this. Now, we know this is 10 feet, we're going to label everything. So the most important thing with these problems is you read the problem, and then you are going to draw a super descriptive picture. So we have this ladder, and the bottom of the ladder slides away from the wall at a certain rate, and it gives us this rate. So this rate of which, now before we write down the numbers, we need to assign letters to each of the sides. So let's say this is C, this is A, B. So now the rate at which B is changing in terms of time, it gives us 1.5 meters or feet per second. Now, it wants us to find how fast the top of the ladder, the rate at which A is changing. So our unknown here, I'm going to write at the top. Always write your unknown at the top. Draw a super descriptive picture. Unknown at the top. And we're ready to solve. We have our knowns, our unknowns, also a known. And let's get to it. So we're going to write down basically two equations that relate to each other. One of them which we can derive implicitly, and the other one we use to find a missing variable, so that we can plug in and find the rate of which we wish to find. So we know the Pythagorean theorem. A squared plus b squared is c squared. C doesn't have a rate, which is problematic, but it all works out when you derive implicitly. So we're going to have c squared equals b squared plus a squared, and let's derive it implicitly. But before, it already gives us a constant, so we can plug that in. Now we have 10 squared, which is 100, equals b squared plus a squared. Now we can derive implicitly d over dt in terms of t on each side, and then we're going to get 0, works perfectly, equals 2b, and then we always have to include our chain rule. And our chain rule is going to be the inside of this function, db over dt, plus 2a, chain rule again, our inside of the function, take its derivative, and what's its derivative? dA over dt. Now this was confusing to me because I thought, isn't it just 1? No, because each of these things, it's not f of x, in terms of x, derivative of x is 1. You have multiple variables, so each of them is treated like a y value. So there's always chain rule, and you just remember this, and you're good to go. So now we don't know what b is. So that's where some problems come in. But guess what it says? The problem says when the bottom is 6 feet long, is 6 feet from the wall. So it's basically saying find this rate when b equals 6. Perfect. Now we can plug this in. 2 times 6, right? And then dB over dt gives us it. It's 1.5. And you start plugging everything in. Plus 2a, that is our unknown, but it won't be pretty soon. dA over dt, what we're trying to find. And we have a good little function here. But our problem is we don't know a. So in this case, instead of relating two different functions, we use the same function twice. So we're going to have Pythagorean theorem again. We know c is 10, so 10 squared equals, and it gives us it so when b is 6 squared plus, then we're trying to find a squared. When we solve this, it's 100 minus 36, which is 64. So now we know A is equal to 8. Plug in 8. Now this works out beautifully. Now we have 12 times 1.5 is going to be 18 plus 2 times 8, 16. 0 equals, and then we have dA over dt. Subtract and divide. Now we have negative 18 over 16 equals our rate, and that is our answer. Of course, you can simplify. And we notice that this is negative because it is falling down the ladder. That's going to be our video for today, explaining related rates. Go ahead and practice these a bunch. They are on the AP exam, so thanks for watching. Goodbye.